Okay, oftentimes with trigonometry and the unit circle, we stick to these examples that we call these special angles. So the ones that were, listed in my unit circle around here. So we do that because those come from simple triangles that we can manipulate. Other angles do not produce triangles that are so easy to know what the ratios of the side lengths will be. There's techniques that will allow us to move from one to another. So for example, there's a certain technique that allows you to say, like, if the sine of some angle is x, what is the sine of twice that angle? Right? And the answer is not 2x, it's something else. But there's a process that lets you do that to compare like an angle to something that's twice as big. You could go in the reverse and talk about something that's half as big. So when you do that, that allows you to say, like, okay, well, if I know 30 and I know this technique, I can get down to 15 and 7.5, and you can kind of start moving around to different numbers through some of those techniques. We're not going to get there quite yet. We're going to start with where you traditionally start, which is just kind of working with these special angles at first. So they say find the exact values of the 6 trigonometric functions for an angle that measures 5 pi over 4 radians. Okay, so let's go to this unit circle first. I don't want to go to the one that's all the way labeled already. So I'm going to say that this is pi radians over here, right? 180 degrees. Now, they said 5 pi over 4, so I'm going to call this 4 pi over 4. Okay, 4 pi over 4, because 5 pi over 4, if I have the same denominator, I can kind of figure out where it is that way. Well, if I had to break this up, I need to get one more pi over 4, right? I need to get to 5 pi over 4, which means that I need to figure out what a fourth of this is and then go that much further. So half of this, 2 pi over 4, would be like up here, which means that 3 pi over 4 would be in the middle. And a step of 45 degrees is what should be equivalent to a step of pi over 4, just one of those pi's over 4. So we want to go another 45 degrees. We want to go from here down to this position right here, right between 210 and 240. Okay, so we are looking at what is going to be a 45-degree angle. We're looking right down here at 5 pi over 4. It's a 45-degree angle pointing directly down and to the left. So we want to look at our 45-degree triangle. Okay, this is how we do it without just having some cheat sheet to look at. We go to our 45-degree triangle, and now they've asked for all of the different functions for that one. So first of all, we are going to be talking about a triangle that is 45 degrees, but it is pointing down in this direction, right? Let's go back to that real quick. So it's going to be pointing down in this direction. So my two values should both be negative. My x value and my y value should be negative. So I should be thinking about 1 negative root 2 over 2 and negative root 2 over 2 over here. Okay, right, because I've moved all the way over to where the angle is pointing down to the left. Okay, so, well, let's just think about all of our functions. So we have sine, cosine, tangent. We've got secant, cosecant, and cotangent. Okay, the way that I kind of remembered these three, it's not a really super great simple way, but I remember that tangent and cotangent go together. And I remember that these two do not follow that pattern. So although I have cosine, and I would think that would go with cosecant, because they both have co in them, they don't. So that's the best I can do for remembering which goes with which. Cosecant goes with sine, and secant goes with cosine. Another way I think of that is the word cosecant is big, and it goes with the small one. Sine is kind of small. Cosine, if I wrote out all the letters, is bigger, and secant is small. So it's kind of like the big word here goes with the small word goes with the big one here. Okay, whatever it takes for you to remember those, come up with your own strategies, but those are mine. It's just to remember that for tangent, the names are intuitive and they make sense. And for secant, they are unfortunately not. Secant and cosecant kind of like go against my intuition. So as long as I know what my intuition is and I know what the opposite of that is, I can kind of keep it straight. Okay, now what these things all are, as a reminder, once we know which one's associated with which, we just flip the fractions. Okay, so the key thing is just remembering which one goes with which, and then you just flip your fraction. Not too complicated at that stage. So if we are looking for the sine of this angle, sine is going to be my y value, right? My opposite side over my hypotenuse. My hypotenuse is 1, so that doesn't really factor into it too much. I just get negative square root of 2 over 2 as my answer. Cosine, it appears that I'm going to get the same thing. For tangent, since opposite and adjacent are the same value, when I find their fraction there, it should just equal 1. Negative signs will cancel out. And then for the rest of these, we just flip them. So for this one, even if I flip it, it'll still equal 1. For these guys, there'll be kind of one extra step. So first of all, we flip it. We have negative 2 over root 2. Negative 2 over root 2. Now, we don't, by conventions, we don't leave square roots in the denominator. And I was kind of looking for why that is. One answer that I came across is that like with it is much easier to, let me show you two different things. So let's rationalize these first, and then I'll kind of talk about why we might want to rationalize it anyways. What I've come across when I've seen an explanation for that. So we're going to multiply by root 2 over root 2. That's going to say 2 root 2 on the top, and it's going to turn my root 2 into 2 on the bottom. Okay, so if I multiply the top and the bottom by root 2, it shows up on the top, and the 2 root 2's on the bottom get rid of the square root, and we're just left with 2. So same thing here. We'd have our negative sign. We'd flip it over. Sorry, I'm not flipping it over right now. We're multiplying the top and the bottom by root 2. And then at that stage, the 2's should cancel out on top and bottom. So we should just get negative square root of 2. Okay, now the reason, let me just, give me a second here and let's just pretend this worked out a little differently for my example. So I'm going to get rid of this and I'm just going to compare root 2 over 2 to 2 over root 2. I'm going to talk about why one of those is better to have as an answer than the other. I'm also going to get rid of these negative signs. I'm just going to kind of box this off and say this is now a new example that I'm talking about. I'm just comparing these two values. Well, sorry, I can't do it that way, right? They would only be equivalent if I had that 2 up there. Okay, so I'm going to compare these two values. 2 over root 2 to 2 root 2 over 2. I'm going to say why the one on the right is better. So here's the reason. With the one on the right, if you can figure out the square root of 2, that is just some number, right? So like there are techniques to do that by hand. We typically don't really teach those anymore. Might be something that would be worthwhile teaching, but we don't really do that anymore. So anyways, we'd go to a calculator and we would say square root of 2, and we'd get 1.41, and the number kind of goes on and on. So we have 2 times 1.41, and that number goes on and on and on. And then we are going to divide that by 2. So in that sense, you've got some really long number, and you're dividing it by 2. Well, if you're dividing by 2, you're just you know how to do that. You're just going to take every unit here and make it half as big. So like that'll get half as big, that'll get half as big, get half as big. That's what it means to divide by 2. So it's the point I'm trying to get across is it's easy to divide by an integer. Dividing by an integer is pretty easy. Now, what is hard to do? What's difficult to do by hand? So this rationalizing stuff, the conventions are kind of the way they are because they were around before we had calculators that made a lot of these steps easy. But I think it's always great to learn how to do these things without the assistance of magical devices. We don't know how they work. So if you look at this, 1.41213562 is much, much harder to divide 2 by that number than to do the opposite, to take this number and divide it in half. Okay, so hopefully that makes sense to you what that logic is, why we try to avoid having those square roots in the denominator. It's because when you try to actually do that by hand, you're just giving yourself a really nasty looking thing to divide by, and that can be very difficult to do. It's much easier to figure out what the value of the radical is and then divide it by some whole number integer. Okay, but that would be the process. With that little aside out of the way, that would be the process for example number 2, finding trigonometric values of specific special angles.